Okay, there are three ways we're going to measure concentration in this class. Concentration from the previous page is just a ratio of solute to solvent, how much stuff you dissolved and how much other stuff. So if you want to measure the concentration, you can do one of three things. Most commonly you'd see, for really small things, you'd see parts per million. This is like if there's an impurity in a big sample of water, like in the pool or something like that, you'd measure it in parts per million. You also have percent concentration. That's either by mass or by volume. And that would be for things that are, things that you purchase, like rubbing alcohol is used, it's usually 40%. Propanol, which is the alcohol in there, by volume, so 40% by volume. And then finally you have molarity, which is the one we'll focus on the most starting tomorrow. Molarity is involving moles, and it's great because it leads to solution stoichiometry. But that's for next week. So we're going to focus on these two today. In parts per million, to calculate that, all you have to do is take, let's see here, parts per million is equal to the mass of your solute divided by mass of solution. That's important because that's to be the total mass of the system. So sometimes you have to add the solute and the solvent to find the mass of the solution. And multiply that by 1 million. So in a problem like this one below, where it says you have 11 milligrams of sulfuric acid and 200 grams of water, what's the resulting concentration of sulfuric acid in parts per million? Well, first you want these milligrams to be in grams. So to get 11 milligrams into grams, you need to divide by 1,000, because there's 1,000 milligrams in 1 gram. And that equals 0.011 grams. Then plug that into the formula. So you have 0.011 grams of stuff dissolved in. The mass of the solution to add it up. Because here it says 2,000 grams of water, and we need to know the total mass, so that's going to be this plus that. It's not a big difference, but it's enough to make a little bit of a difference. So you take 2,000 grams of water plus 0.011 grams of other stuff. You do that first with this parentheses down there, then multiply that by 1 million. And the resulting answer is 5.5 parts per million. For parts per million, you have to put the ppm as your label. And for this percent concentration problem, that's a little bit different, but it's just a straight percent, so that can be kind of nice to do. Percent concentration is equal to the amount of solute divided by the amount of solvent, solution, times 100. So again, it says solution, so you might need to add. And if you can read this problem, it's a little murky here. It says an aqueous solution contains 100 grams of sulfuric acid and 2,000 grams of water. Calculate the percent concentration. So you have the 100 grams of sulfuric acid. That is your solute. But the solution, you have to add these two numbers together. So the total solution is 2,000 grams of water plus 100 grams of H2SO4. So you're taking 100 and dividing by 2,100, multiplying that by 100, and I think it equals 4.76%.